record myself, and then you're gonna watch on. So it is useful. It is useful. It's silly, but it's useful. All right. That's never gonna happen. What do you think this is? Social studies, and they don't teach anything. Yeah.
It's so true. It's not even funny.
All right. It's just different. You can. It almost seems like sometimes when they show movies, oh, we're watching a movie, but you're actually learning a lot, whether you realize it or not. So I'm not completely dissing them, just a little. Now, this is a diatomic mixture, right? This could be N2 and this could be H2. So that's another mixture of elements. And if you did, I'm trying to just think of that. Those are the two like go-to mixtures of elements you'll see. But sometimes they do diatomic and monatomic. Oops. Make sure. See, I made a mistake there. Make sure they're touching, right? Because a molecule means they have to touch. All right. And then if you have, so what you had this, and then you did this, right? Yeah, Bella had this. That's what she had. Technically, you're right. But because they're all the same symbol, let's say this is oxygen gas, that would make this oxygen, right? I know that looks the same, but technically it's not a mixture. Does that make sense? But I think I'd probably give it to you on a Regents because you got the point. You know, you got it. But it would be better to do this. So this could be O2 and this could be neon. All right, that's a mixture of elements. All right, am I making sense? So remember, a mixture, you're going to have particles that look different. Elements need to be either atoms or molecules. That's what elements are. And the molecule needs to be two of the same. So they have to be the same color or just individual circles, which is an atom. So that's what elements look like. Mixture of compounds. You guys could go almost anywhere with this. I forgot to mention this yesterday. Water is called the Mickey Mouse molecule because it looks like Mickey Mouse's head. Water looks like this. Or you could do this. Fill this one in, and then that. Kind of looks like Mickey Mouse, right? That's called water, a Mickey Mouse. Well, one of them. So I tend to do this just because it's easier or less shading involved. All right, so this would be my oxygen and these would be my hydrogens, right? So there's my H2O, and remember water is bent, so it looks, so again, this doesn't look like Mickey Mouse's head, but in reality, I really wish they made these kits more realistic. So in reality, the oxygen is a much bigger atom, so that's like the head, and then the ears are the smaller hydrogen, so this red one should be bigger, but that's what water looks like. So let's say you had water in here. Okay, so a couple of those. And then let's put in this one, CO2. I'm just trying to use examples I talked about yesterday. Carbon with two oxygens. So you would have, there's carbon in the middle, and then your two oxygens. All right, and then we'll do another one. So there's a mixture of compounds. What makes it a compound? Two different colors. Element, two of the same colors. Compound, two different colors. This is one type of compound, CO2, and this is H2O, another type. So that's a mixture of compounds. You could also do something very simple. Okay, you can just do something that looks like this. Okay, there's one type of compound, and then someone throws something else out there. What else could I do? Another compound that looks different than that. What could we do? There's almost no wrong answer. Someone give me an idea. Wants to be wrong? You can't be wrong. Just take two different colors and put them together.
You could have like a white, a black, and a white.
White? Well, I just did that one. Give me something different. I just did white, black, white.
Black, white, black.
Black, white, black. All right, so you want to do this?
Yeah.
Yeah, that's different. Good. And I hadn't done that yet. So that's different. Good. That's one type of compound. That's another type of compound. Okay, so that would be a mixture of compounds. But here's where some kids, they kind of blow my mind a little bit. But I can understand. If you don't really fully get it, I can see why they make this mistake. They go, okay, I'm going to draw that. That's one type, and then they do this. They say, oh, that's different. And I say, no, it's not. And they're like, what do you mean? I'm like, just flip it. these actually exist in real life, so they're three-dimensional. So if I'm looking at this molecule from my perspective, which side of my body is the yellow one on?
You're right. Left.
My left. Which side is it for you?
Right.
You're right. Well, if I turn it around, is it the same exact molecule? Yeah. Okay. It's like looking in a mirror. It's the same person looking back at you. Hope so. Let's get some stuff going on. So don't be confused by that. All right. So really, I use the warm up to kind of help further teach this stuff. I know we didn't take notes. The plan is the rest of the period go through the worksheet here together. Take a little bit more notes as far as just a few more practice problems like this. We'll pick up where we left off yesterday. Except we didn't finish the two on the right, did we?
No.
No. So I'll go through those again. We'll do a little bit more. I'll give you the other worksheet. No, I won't. So you won't have homework. I'll give you that worksheet Tuesday to do in class. Since I won't be here, that's better use of time. So I'll probably have you work on the worksheet. Maybe like 15 minutes on your own, or 10 minutes on your own. Pair up for 5 minutes. I'll have the sub read the answers. Obviously, she's not a chemistry teacher, so she's not going to fully be able to explain everything, but she reads the answers. Maybe you guys can kind of figure it out together as a class. And then either I'll have new work, or like I said, I'll record myself for like 15 minutes. You can watch that and take notes. You'll probably have homework due Wednesday. So that sounds like a plan. All right, so no homework. I'll just give it to you on Tuesday. All right, you can clean those off. If you need a eraser, you can do that here. Just erase it over the floor, though. Not my desk. And then we'll go over the homework.
Oh, I just walked right in front of the camera. I didn't even realize. Hey, Nicole. Hey, Nicole.
Hopefully she's gonna watch this.
What did you say?
I said, did you say hi to Nicole? Hopefully she's gonna watch this.
No, I didn't say hi. I just didn't even realize I walked right in front of it.
All right. Okay, here we go. Answers to the homework. Oh, and I gotta get back those quiz. Oh no, I gotta wait for our friend here.
I'm coming during lunch, and I won't forget this.
You sure you can come? You can come 6. That's fine.
Yeah.
Apparently, I gotta. So I'm being good this year about not wasting extra copies, but I need to print one more for myself. All right. All right. Let's go over this side. I would assume was easier. No. This side is easier.
Yeah.
Okay, we'll go over the easy side first. All right. Okay, so everybody has it in front of them, so I don't need to draw it on the board. Number 1, which contains a gas. So, I obviously you can tell I handwrote this. I probably should have. What are you laughing at, Zeke?
My handwriting is awful.
Oh, wait,
I had to get Miss Milano to decipher all your words on the back.
Are you serious?
I couldn't read.
Oh, these aren't mine. This is not mine. I don't write cursive.
Oh, yeah, so I hate cursive.
This isn't mine.
Oh,
Like
no, I can.
this word, they
This
all
one?
look the same.
This one?
Yeah.
Yeah, that's pressure, right? Yeah.
I didn't know.
Yeah, that's not me. I don't know where I got this worksheet from. I mean, this side, that handwriting is fantastic. All right. Now, a gas. So what does a gas do?
It wants to stay away from us.
Yeah, it fills up the container. Fills up the container, okay? So it won't be sitting on the bottom of the box. So look at B and look at D. They have solids in them, okay? B doesn't have a gas, but A does. So A is a gas. So the answer to 1 is A. But really what I was going for is C and D also contain a gas. So really I was looking for A, C, and D for number 1. Yeah, so that I didn't really word the question very well. So, so regardless of what you thought was the answer, the goal is right now, you understand? So A, there's a gas because it's moving all over. C, there's a gas because it's filling up the box. And D, there's a gas, that's the dark ones. Does everybody understand that now? Okay. Number 2, which contain atoms. Now, don't have the argument with me. Everything contains atoms, yes. But when you're talking about particle diagrams, what is an atom? It's one circle. One circle is an atom. two together is called what? Molecule. So you're looking for the boxes with just one circle in it, right? Well, circle's not touching. A, that's a molecule. There's no atoms in A. B, there's no atoms in B. And again, kids want to argue, yeah, but A and B are molecules. Molecules are made of atoms. I get it. But I'm just trying to explain how the Regents expect you to answer these questions, right? So C has atoms. That's the white circles that are by themselves. Those are atoms. And D is supposed to be, those first two look like they're almost touching. That's just poor drawing on my part. So D is supposed to have atoms as well. Everybody follow me on that one? Okay, because besides the fact, could be on the Regents, and I want you to learn and understand what you're doing, you will have a quiz on just particle diagrams next week. And I usually do that quiz in lab, actually. So just, you need to be able to do this soon. 3, which contains only molecules. So that means no atoms, only two touching. So that would be just A and B. A and B have molecules. C and D have atoms in them as well. Where the heck are we? 4, which contains a compound. B is a compound. What's a compound? How do we know? What are we looking for when I say compound? Two different colors touching. So B has a compound, and what else? C has a compound. So B and C have compounds in them. I'm going slow on purpose. Any questions? Anybody confused? Any clarification here? All right. Which is a pure substance? So now, this cannot be a mixture. It has to be an element or a compound. There cannot be a mixture of different things in the box. So there's two answers. A or B. A is an element. B is a compound. Those are substances. C and D are mixtures because there's different particles inside the box. Everybody still with me? Okay. Let's see. Which is a mixture of elements? Number 6. Go ahead, Tyler. Which one? Well, what's mixture imply?
Oh no, it's different. So it's
No. What's mixture mean? So, hold on, back to this here, and trust me, you're not alone. Which is a pure substance? A and B are pure substances. Why? Let someone explain. Why is A and B considered pure substances?
Because they have like the same colors. Like B, they have the same colors corresponding to each other and they don't change.
Right, so uniform, right? Every particle in A is uniform, identical. Every particle in B is identical. That's what you mean, right? So C and D are mixtures because C has two types of particles. C has, so box C has this and this. Right? That's one type and that's another type, so that's a mixture. And then box D has this and that. So C and D are mixtures because they have different particles inside the box. So now what was the question asking? Which is a mixture of elements? Okay, so now I'll tally it back to you. Is it C or D? D, yes. It's D because this here is a compound. Zeke, why is that a compound? Two different colors touching is a compound. Element, 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 element. And so those are all elements because they're the same color, right? Obviously one circle is just one color, right? So that's an element. Two together, if they're the same color, so you're only ever going to see two white or two black. You're not going to see anything else as far as a diatomic element. That's the only options you have. Every other molecule with more than one is going to be a compound because it's going to be white and a black, or two whites and one black, or two black and one white, or whatever. So those are elements because they're the same color touching. Hopefully that's making sense. Okay. Where are we? Which is a mixture of a compound element? It's got to be C because we just went over the rest of them. So a C, in box C, there's your element, there's your compound. Compound, element, so there's your mixture. Are you sure this side was easier? It's not supposed to be. Okay. Who contains a solid? B and D. How do we know? They're at the bottom. What else? Close together and uniform, very orderly, right? And again, I'm not the best artist, but you can tell that they're supposed to be close together at the bottom. All right, where are we here? Which contains water? I forgot to mention that yesterday, so it's C because Mickey Mouse. That's what water looks like. 10, which could be fluorine gas. Fluorine is part of Hunkelbrief. It ends the Hunkelbrief. Yeah, that's the Hunkelbrief. Fluorine looks like that. It's F2. So F2 is a Hunkelbrief diatomic. So which one is that? A. All right. Who's it going to be? I can call on you, or you can volunteer. We have 2 boxes. Someone's drawn in one. Someone's drawing in the other.
Can I draw on the second?
She wants to do the second one. Come on up. Who wants to do the first one? Any volunteers? All right, Bella, come on up. You guys are on camera though. Just go ahead. I know you don't, but so what if you're wrong? We're wrong all the time. Have I talked to you guys about failure yet? I like to throw in some life lessons, not just chemistry. You ready for this, Sean? In life, you will learn more from your failures than from your successes. It's a fact. Can you back up a little bit? Just because I feel like when I walk here, I'm like in Tally's face. That's a little better. It makes sense. You learn more from your failures than successes. Why, Zeke? Think about basketball. You keep losing. What do? Right, you work harder so that doesn't happen again, right? That's the reason. That's the reason. One year one of my first couple years teaching, I only had like 70-something% passing the Regents, and like, I was not acceptable. I was like all upset about it. So the next year, I tried so hard, came up with all these new things. I became a better teacher because of that bad year. And the kids did better. You know, it wasn't like I had 100% passing, but they did better. But I had all these new labs and stuff. The point is, it's okay if you're wrong. And you'll learn from it. You'll work harder, you'll get better. But that's only if you care. See, that quote only applies to people who actually care. If you don't care about failing, that's a whole nother problem. All right. Are they right? What's the first box even asking for? Mixture of copper and hydrogen. We'll come back to that. This one, gaseous binary compound. I hadn't taught that yet. So this is a good time to learn. What's binary mean? Two. Two what? I haven't taught it, so there's really no way you would know this. Binary means 2 different elements, not 2 different atoms. So that is a binary compound. So something like NaCl. Water is also binary. Kids get all kind of whacked out here. They're like, wait, binary means 2. I count 1, 2, 3. It has nothing to do with the number of atoms. It has to do with the number of elements. There's 2 elements in water, H and O. Yes, there's 2 H's, and that doesn't matter. So that's a binary compound. Okay? I'm going to show you another one that's really confusing. It's on the worksheet you'll get Tuesday. Kind of looks like a flower, sort of. That's CCl4. Guess what? It's binary. 1, 2 elements, carbon and chlorine. Yes, there's 5 atoms. That has nothing to do with the word binary. So you are right. This is a binary compound because it's full of water, and water is a binary compound. So we could have filled this whole thing up with this. What's it say? Has to be a gas, right. So we could do this. could do this. Okay? That would also answer the question. That's a binary compound. Okay. So hopefully you're kind of picking up some things here and learning a little bit. You know, you don't always have to learn from notes, right? You can learn from labs and worksheets and homework. Okay, now let's fix this, Bella. But I appreciate you offering to do it. Okay, so if you look over there, Bella, copper is number 29, and everybody too, trust me, you are not the only one who didn't do this right. Copper is 29, it's black. What does that mean? Solid. Now, is copper a Hankelbrief? No, the part is Cl. So it's not copper. So copper would be at the bottom of the box, very organized. That would be a solid. So there's copper. So that could be your Cu solid. Now, I made kind of a huge jump here asking you to do this, but we didn't really even learn it yet, so don't feel bad. And we're going to learn, right? Learn from our mistakes. What's the other thing? Hydrogen. Hydrogen is a diatomic. It is a Hankelbrief. So Bella, what would that look like? It's diatomic. This is monatomic, meaning one atom. Two, right. Now, but here's the part that's going to be a little technical. I can't do this. Not really. You could, I'd give you credit, but it's not really the best way. Why? Yeah, I already, so honor regents, they're going to do this. They're going to say this is an atom, and they're going to say this is a different atom. That's what they're going to say. And they're going to say, all right, draw whatever. Draw a compound. They'll give you the key, and then you draw it. So if this is already being used for copper, we can't really use it for hydrogen, so we would just do this. And now that's going to be H2. And it's a gas, so it would kind of fill up the rest of the box. And it's a good rule to always draw at least like 5 particles. And obviously, you know, I'm not good at drawing or writing for that matter. So you guys don't have to make it look pretty, just answer the question, right? So that's solid copper, and that's gaseous hydrogen, H2 is the gas. So again, so I thought this side was hard considering we haven't really learned a lot yet. So I kind of used it to help us learn, all right? So hopefully a lot of that makes way more sense now. Flip it, let's go over the other side. And whatever time is left, we will continue with this. All right. I'm just going to read all the answers. All right. Which number 1 is? See. You know what? Every year I do the same thing. I use this and I don't remember to look at it closely. I don't like this sheet, and here's why. Whoever I got this from, the solids, liquids, and gases are all floating. So really, what this should look like is this. So the bottom here, that should be the bottom of the box. Because solids don't float. This is supposed to be a solid, that's supposed to be a solid, but they got them floating the way they numbered the boxes. That's supposed to be a liquid, you could argue a gas, and that's supposed to be, I think, a solid. I don't like this worksheet. These two are gases. So I can see maybe why you thought it was hard because of that. Here we go. Number 1 is supposed to be 3. I'll explain each one in a minute. Number 2, 5. Number 3, 1. Number 4, 2. Number 5, 6. Number 6, 2. Number 7, 2. Number 8, none. Gotcha. 9, 5. 10, 6. How many did you get, Zeke?
1, 2, 3, 4, 5, 6, 7.
Oh, you got 7. That's not bad. All right. Which could represent BR2? BR2 is a Hankelbrief. It told you BR2. BR2 looks like this. That's Br2. And Br2 is a liquid. Why? It's blue over there. Bromine's a liquid. So the only two boxes with diatomic elements, 3 and 6, right? Two of the same color is diatomic. So 3 and 6 are diatomic. 3 is a liquid, 6 is a gas. Again, I don't like the worksheet, I understand that. I really need to scrap this and just make up a new one. Maybe I will finally do that this year. So if I don't do it now, I'll forget again. So I need to do it this year for next year. Okay, now number 2, monatomic. That's atoms by themselves. So that's either box, oh I'm sorry, back to number 1. I forgot number 1. Box number 1 is also diatomic. So 1, 3, and 6 are all diatomic, but 1's a solid, 3 is a liquid, 6 is a gas. Sorry. Okay, number 2, monatomic. That would be boxes 2, 4, or 5. That's atoms by themselves. And the only one that can diffuse, what's diffuse mean? Yeah, go through the air, okay? If I spray some cologne or Axe or whatever these kids use these days, okay?
Something that smells
Axe is
disgusting.
disgusting.
Okay, alright. What do you use, Zeke?
I don't use like
What do you use?
Hugo.
Hugo. False. Okay, if I spray some Hugo, if I spray a lot of it,
What?
I'm just saying, I don't know.
It smells good.
It's not
Yeah.
funny. Whatever, use cologne. Kids use cologne. People, adults use cologne. Alright. Does anyone know Mr. Marcel?
He has
Does
a
it?
certain smell.
He has a smell.
Yeah.
I
He,
hate that
he
smell.
smells like Old Spice.
You
That's
smell
Old Spice.
you smell him
Yeah.
before he enters the
Oh,
room.
this is, I'm being recorded this, but Mr. Marcel, you're the man. I like Old Spice. It reminds me of my dad. So, anyways, so the point is, you can smell the cologne. If I spray it here, you might smell it in the back of the room. Eventually, if I spray enough, how does it move from here back there? It's called diffusion. Okay, it goes through the air. So gases and vapors can diffuse. Is this table going to diffuse to the back of the room? No. The liquid water, is it going to diffuse? No, it's not. So the answer is 5 or 6. It says which one will diffuse, but it says monatomic, right? So that's why it's 5. Okay, number 3, iodine at STP. Iodine looks just like that on the board, except it's a solid, so that's why it's number 1. Iodine is a solid. Any alkali metal, so group 1, LINA, KRB, CS, and FR are all monatomic. They're not Hunkelbriefs, that's why it's 2. They're solids. Diatomic exert the most pressure. So diatomic looks like that on the board. What do you mean exert the most pressure? The ones that are the hottest. Because if they're really hot, they're bouncing around. And if you heat up something that's sealed, a gas especially, it could blow up because it builds up pressure. So that's why 6 has the most pressure, and it's diatomic because it's at the highest temperature.
Wait, what?
So number 5, it wants to know, so out of the diatomics, you got box 1.
Oh, I thought you were in the question. Continue.
Okay. Number 6, solid strontium. At STP, you don't know what STP means yet. It stands for standard temperature and pressure. It's kind of irrelevant right now. But which one is solid strontium? Strontium is SR. It's not a Hunkelbrief, not diatomic, so it's number 2. Individual atoms, and it's a solid, so number 2. Regular crystalline particles in cobalt. That's number 2 as well, because crystalline and solid are the same thing. So crystalline means solid. So number 2 is the only one that's a solid and monatomic. Cobalt is CO. It's not a diatomic, therefore it's monatomic. Number 8, which represents oh that's not there. O3. What would O3 look like? That's O2. What would O3 look like? Yep. That's actually what O3 looks like. That's ozone. Don't breathe that. Number 9, radon, monatomic gas. That's number 5, because it's monatomic and it's a gas. And then these particles have, what's entropy mean?
The concentration-ish thing.
Chaos. Lots of movement. Lots of movement is chaos. So which one would have the most movement? The hottest one. Number 6. The hottest particles move the fastest, so that'd be the most entropy. Okay, that's all we got time for. Tuesday, you will have some work to do, and maybe taking notes, watching me